Today's video is on the multiplication properties of exponents. Our target today is I can use multiplication rules of exponents to simplify algebraic expressions. This is different from our work we've been doing the last couple of days in class because we are now moving from numerical expressions to algebraic expressions, meaning our expressions will now contain variables. The same multiplication rules of exponents apply to numerical and algebraic expressions. So let's review our product of a power property, which says if I have like bases being multiplied, I keep the base and I add the exponents. My power of power property says if I have a power raised to a power, then I keep my base and I multiply my powers. So a lot of times I'll put a little dot in there to represent the multiplication. Then the last multiplication property is power of a product property. And it says that anything inside parentheses that's raised to a power, this power must be distributed or handed out to everything inside the parentheses. So a times b to the mth power is a to the m times b to the m. So we're going to use these three properties today to simplify algebraic expressions. Let's look at our first three problems. So I kept these pretty simple. First, we're reviewing with just numbers. So if I have 5 to the 8th times 5 to the 3rd, I have like bases being multiplied, so I'm going to add the powers. I have 5 to the 8 plus 3. And 8 plus 3 is 11. So the answer for this problem is 5 to the 11th power. Now the next one illustrates the power to power property. So I have 7 to the 4th raised to the 2nd power. So what I'm going to do is I'm going to multiply these two numbers. So this is going to become 7 to the 4 times 2. And 4 times 2 is 8. So this is going to be 7 to the 8th power. All right, number 3 is illustrating the power of a product property. So we have negative 5a raised to the 3rd power. So this 3rd power has to go to all these things. It has to go to negative 5, and it has to be handed out to the a. So this problem becomes negative 5 to the 3rd power times a to the 3rd power. Make sure that negative is raised to the 3rd power because it is inside the parentheses. It is also being raised to the 3rd power. So this negative 5 to the 3rd power, since we have numbers and letters, we are now going to start simplifying our numbers. I want to know what negative 5 to the 3rd is. So I take negative 5 times negative 5 times negative 5, and that gives me negative 125 a to the 3rd as our final answer. All right, let's move on to 4 more examples that get a little bit more difficult and that put these rules together. So we're not just going to be looking at each rule separately, we're going to be using them together. All right, so number 4 says I have 3y squared times 2y raised to the 3rd power. So the first thing I have to do here is I have to hand out that power. I have to use my product of a power property and give this 3rd power to the 2 and to the y. So this expression now becomes 3y squared times 2 to the 3rd, y to the 3rd. All right, now I'm going to look at my numbers, and I see I have a 3 and a 2 to the 3rd. I'm going to evaluate 2 to the 3rd. I want to know what it is. So 2 times 2 is 4, and 4 times 2 is 8. So this becomes 3y squared times 8y to the 3rd. Now this is where it gets tricky. The numbers you still treat like numbers. 3 and 8 are being multiplied. That's the operation that's going on with all of these parts of this term. They're all being multiplied. So 3 times 8 is 24. So my coefficient of this expression is 24. Now I have my y's. My like bases, y squared and y to the 3rd are being multiplied. So I keep the base and I add the powers, 2 plus 3. So this expression simplifies down into 24y to the 5th power. is my final answer. So notice we started with numbers and y's, and we simplify, we want to have one number and one y in our term. All right, let's look at number 5. Number 5 says I have negative times 3x squared times 7x to the 4th squared. So the first thing I have to do is use that product of a power rule and hand this square to the 3 and to the x. Notice I'm not handing it to the negative because it's outside of the parentheses. So I keep my negative out here. Now I have 3 squared times x squared. Same thing with the square in this part of the term. I have to hand the square to the 7 and to the x to the 4th. So this becomes 7 squared times x to the 4, and when I have a power raised to a power, I multiply them. 4 times 2. So I'm going to simplify. Remember, this negative is not squared, it's just 3 squared because the square is only touching the 3. So the negative hangs out in front. 3 times 3 is 9, x squared, and 7 times 7 is 49, x, and 4 times 2 is 8. All right, now I'm ready to work with my coefficients. I'm going to take negative 9 times 49. Remember, with the coefficients, I do the real operation, the multiplication. So negative 9 times 49 is a negative 441. And now I have x, and since I have like bases being multiplied, I'm going to add my powers, 2 plus 8. So my final answer is negative 441 x to the 10th power. All right, number 6. Number 6 says I have negative rs times rs cubed squared. So this right here, there's no power on the outside of there, so I can just drop the parentheses and I have negative r times s. This square has to be handed out to the r and to the s to the 3rd. Remember, any variable that you have without a power has that invisible 1 there. It's understood that it's r to the 1st power. So you are still multiplying 1 times 2 when you hand the 2 to the r. So this becomes r squared s to the 2 times 3, which is 6. Now I'm ready to look at my like bases being multiplied and add the powers. Sometimes it helps that you put the 1 there so you remember that you're adding 1 when you just have an r and an s. So the negative just means our term is negative. R to the 1st times r squared. Here's your like bases. Add the powers. 1 plus 2 is 3, so we have r to the 3rd. And then s to the 1st times s to the 6th will be 1 plus 6, so that'll be s to the 7th power. So our final answer is negative r to the 3rd, s to the 7th. All right, for number 7, we have negative x raised to the 4th power times negative x to the 3rd power times negative x squared. So this this negative and the x are both being raised to the 4th power. So this is negative x times negative x times negative x times negative x. So that's going to become a positive x to the 4th, because if you have even negatives, it becomes a positive. So negative x raised to the 3rd power is negative x times negative x times negative x. So that's going to give you 3 negatives. So this is going to be a negative x to the 3rd. And then negative x raised to the 2nd power, so that negative is also squared. That's going to be a positive x squared. So now we have like bases being multiplied, so we'll add the powers. This negative here that's with the x to the 3rd just becomes our coefficient. Remember, it's a coefficient of negative 1, but we don't put the 1, we just put the negative. And then x to the 4 plus 3 plus 2. We're going to add them all together. So we get negative x to the 9th power as our final answer. All right, I have 4 more examples for you. So number 8 has 3a to the 3rd times 2a squared. So again, we'll use that product of a power rule, and we'll hand out the powers to everything inside the parentheses. Now notice this 2 only goes to the a and the 2 because the parenthesis stops here. It only goes to what's inside its set of parentheses. So this becomes 3 to the third, a to the third, times 2 squared, a squared. Well, 3 to the third is 27, a to the third, and 2 squared is 4, a squared. So now we'll multiply the coefficients, and we'll take 27 times 4, and 27 times 4 is 108. So we have 108. And then we have like bases, so we'll keep the base, which is a, and add the exponents. 3 plus 2 is 5. So this becomes 108a to the 5th power. All right, number 9. This 2 is going to be handed out to the w to the 3rd, x to the 4th, and the y. And this 4 is going to be handed out to the w, the x squared, and the y to the 3rd. Remember, when you have a power raised to a power, you multiply. So here we're going to take 3 times 2, so that's w to the 6th. 4 times 2, so that's x to the 8th. And remember, this y has a 1, so 1 times 2 is 2, so we get y squared. And we're going to multiply that times 1 times 4, so w to the 4th. 2 times 4, so x to the 8th. And 3 times 4, y to the 12th. Now we have like bases being multiplied, so we look at the w's. W to the 6th times w to the 4th. So 6 plus 4 will give you w to the 10th. X to the 8th times x to the 8th will be x to the 8 plus 8, which is x to the 16th. And then we got y squared times y to the 12th. So 2 plus 12 gives you y to the 14th power as our final answer. You can't add any of these powers together because we do not have like bases. W, x, and y are different variables. They are not alike. All right, last 2 examples. Number 10. So here I have 4 that needs to be handed out to the s squared and the t to the 3rd. So I'm going to have s. 2 times 4 is 8, and t, 3 times 4 is 12, to the 12th power. And then I still have an s, remember, that's to the 1st power, and a t to the 1st power. So now I have to add my exponents for like bases. So s to the 8th times s to the 1st is s to the 9th. And t to the 12th times t to the 1st will be t to the 13th. So s to the 9th, t to the 13th is my final answer. And finally, number 11. This negative out here is not raised to the 2nd power, so it's going to stay in our answer. That means our term is just going to be negative. But I have to hand this power out to both the m and the n. So this will be m to the 1st times 2. So that's m to the 2nd power. And n squared raised to the 2nd power, you'll multiply 2 times 2 to give you n to the 4th. And that's your final answer. Negative m squared n to the 4th. All right, so these 11 examples will help us to reach our target that I can use multiplication rules of exponents to simplify algebraic expressions. So we'll practice more of these tomorrow in class.